So welcome everybody. So what we want to do today is take you through a little bit of a technical overview of cloud.gov. We pre-recorded a series of videos that will kind of draw some pictures and explain at a high level what cloud.gov isn't. A couple caveats to this. Cloud.gov is big, and so this is by no means a technical deep dive into any particular topic. And this is by no means entirely comprehensive of all of the different things that actually go into the platform. Our goal here is really to answer some of the common questions and give you kind of a big picture overview. So in going through this, we've recorded 6 videos, and the cadence will be we will play a video and then give you a chance to ask some questions if you feel like doing so. We'll also have some time for some questions at the end. So we're going to go through first with a technical overview. That's going to be the longest section, just kind of drawing a larger picture of what actually goes into making a cloud.gov instance. And then we'll go into a little bit more detail on what actually happens when you deploy an application to cloud.gov. Next, we'll talk about answering just one of the common questions that we get all the time is, how does traffic actually get into my applications inside of cloud.gov? And then we'll do 2 videos back to back, one on just general service brokers, and then an example of our CDN or content delivery network service broker. And then finally wrap up with routing traffic into CDNs, because that process is a little bit different. So that's the plan. I think we should just dive right into it. I'm gonna have to do some screen share stopping and starting real quick. But I'll let this video play, and if you have questions, again, please post them in the chat, and we'll take a few minutes after this video before we go on to the next one to hopefully answer some of those questions.
So if you're a cloud.gov user, you probably know that the open source project called Cloud Foundry is at the heart of cloud.gov. However, it takes a lot to actually build a platform around Cloud Foundry, as well as to provide the services to those end users. And that's really what we're going to talk about in this section. Now, you also probably know, if you're a cloud.gov user, that most of what we do actually runs in AWS and Amazon Web Services in their GovCloud offering. GovCloud is different than Amazon Commercial. Amazon Commercial Cloud has more services and different features. GovCloud has FedRAMP approved services. We run in a single GovCloud region in US West right now. There are only 2 regions in GovCloud, US West and US East, but we run in the US West region. And most of what you're going to see on this board is actually deployed to AWS GovCloud in US West 1. But not everything. We actually use commercial for some of these elements as well too. So before we can even deploy Cloud Foundry inside of GovCloud, we need to set up a bunch of infrastructure. We use a technology called Terraform to do that. Terraform is an infrastructure as a code solution, so it allows us to define what our infrastructure needs to look like. And there's a couple key components that I'll highlight here. And again, I'm not going to go into too much detail in this section, but we want to deploy our Cloud Foundry instance in GovCloud inside of a VPC, or a virtual private cloud. This gives us essentially a safe space where we can do things like apply security groups, which control ingress and egress into that particular virtual private cloud. We can do things like define the subnets or networks that are available and who can access those networks as well. Again, another layer of security. And it allows us to provide other policies, define things like IAM users, etc. And we do all of that through Terraform. Now, the Cloud Foundry instance itself is also going to need a few things provisioned ahead of time. One of those things is some databases where it can store its information. And for that, we use Amazon's RDS, or Relational Database Service. And we provision those also through Terraform. The Cloud Foundry instance is also going to need a place to store objects, or a blob store. And we use, again, Amazon's S3 as the object store for Cloud Foundry, again, provisioned by Terraform. We're also going to want to be able to get traffic into this Cloud Foundry instance and ultimately get traffic so that your end users can access your applications. And there's two components that come into that. One is we need DNS. And for that, we use Amazon's Route 53 service, which is their DNS service. And this is actually running in AWS Commercial and not in GovCloud. The other thing we will end up needing is load balancers to load balance traffic coming into our Cloud Foundry instance for different reasons. And for that, we use Amazon's ALBs, or application load balancers. You may have heard of ELBs before, or elastic load balancers. This is the new version for Amazon. And so these provide load balancing services for our different app domains, for your specific agency domains if you're bringing a custom domain, and a few other things that we'll get into throughout the various videos here. So once we have all of these things provisioned before our Cloud Foundry instance, again using Terraform, now we can actually deploy a Cloud Foundry instance. And for that, we use a different automation tool called Bosh. And Bosh is a little bit different from Terraform in that Bosh is essentially deploying clusters of VMs. And so what Cloud Foundry really is a sets of clusters of VMs. And what that really means is that when we deploy Cloud Foundry, it is essentially running on Amazon's EC2 or Elastic Compute instances. And it is essentially a cluster of different VMs with different software on them. Now, the reason we don't use Terraform to deploy that is because Bosh is a full lifecycle management automation tool. So it allows us to do things like update Cloud Foundry. As new releases from the open source project come out, we can deploy them as we do multiple times a week to provide patches and new features, all with zero downtime. So there's some significant differences between what Bosh does and Terraform does. But we use Bosh to actually deploy anything that is running on Amazon's EC2 or Elastic Compute instances. Now, once we do that, we obviously have a running Cloud Foundry instance finally. That Cloud Foundry instance is using RDS and S3 for its storage. It is essentially, like I said, a cluster of virtual machines. And then when traffic is coming in, it's getting resolved through our DNS and Route 53. It's getting load balanced through our application load balancers, and then it's finally coming into that particular Cloud Foundry instance. So that gets us a nice running Cloud Foundry. Now, as operators, we need to have some visibility into this particular Cloud Foundry instance. And so we also deploy a fairly significant set of tools, typically, again, through either Bosh or Terraform, that give us visibility. And I'm not going to get into too much detail here, but I will highlight just a few. And so we deploy Elasticsearch, Logstash, and Kibana, or you may hear it called the Elk Stack. And this is basically deployed to give us visibility into platform logs. So we gather and aggregate logs from the entire running platform, and we have visibility into the Elk Stack. Now this is different if you're a Cloud Foundry, or excuse me, a cloud.gov user, and you're going to logs.fr.cloud.gov. This is actually a different instance. We'll talk about that one here in a second. In addition to the Elk Stack, we use another open source technology called Prometheus. Prometheus is providing alerts for us, so it lets us set boundaries on metrics and allows us to get alerted when things are kind of getting outside of the norm. We use another technology called Grafana, and that provides us visibility into running metrics over time. So we can see how the different components within the entire platform are actually behaving, and we can see things like CPU utilization and memory utilization, requests per second, etc., all through Grafana. And that again is also Bosh deployed. So everything kind of over here on this side of the picture is really an operator concern. And actually everything in the middle is really an operator concern, except for the experience that Cloud Foundry is bringing you, which is essentially an experience of bring your apps, we'll run them. You don't need to worry about all of this other complexity. But in addition to this, the basic open source Cloud Foundry and the compliance and security and monitoring that we apply to it, we also want to provide additional services to you, our customers. And so we add additional services to this Cloud Foundry instance. So one of those things I've already mentioned before is the Elk Stack. And so if you go to logs.fr.cloud.gov, what you as an end user of cloud.gov will see is all of your application logs. So this is a place that you can go using Elasticsearch Log Session Kibana to actually see all of the logs for all of your applications inside of your organizations and spaces, all of the applications that you as a user of the Cloud Foundry platform have access to. And we manage that for you, so you don't need to actually do anything for that. You can also use your own log drains, but we want to make this easy for you as well. So then we also BOSH deploy a large number of brokered services. And we're going to talk more about what are brokered services and what are service brokers in particular in a future video here coming up. But each of these components is essentially a piece of software that provides automation around the lifecycle management and credential management of the different services that we bring to you, the end user of cloud.gov, in a self-service fashion. So you can go into cloud.gov and you can provision instances of Amazon's RDS according to bounds that we've set up. So if you need a MySQL database or a Postgres database, you would use Amazon's RDS to do so. And we've predefined plans that allow you to pick and choose the size of the cluster that you're creating, and you know, the flavor of the cluster, whether it's MySQL or Postgres, et cetera, all using a standardized API. And like I said, we'll talk more about that as we go through the next sections here. So we also manage service brokers for Elasticsearch, Redis, and Amazon's S3. If you've used the previous versions of Elasticsearch and Redis, those actually were not using Amazon's actual Elasticsearch and Redis offerings. The new versions are, and they're far more stable, they're far more robust than what was there before. But those services didn't exist when the other offerings were put in place. But again, through service brokers that we manage through BOSH, you have the ability to basically go in and say CF create service and provision an entire Elasticsearch cluster. And you don't need to know anything about how to provision that cluster, how to manage credentials on that cluster. All of that is encapsulated again through these brokered services. And then the last two services that I'll highlight here before moving on are our custom domain service and our CDN service. And both of these have actually been merged into a new offering, a new service broker. But again, that is custom code and custom automation that we as cloud.gov operators write and maintain. And that allows you to basically bring your domain to cloud.gov. So you might have myagency.gov and you want to use cloud.gov to host that. We make that trivially easy for you to bring that custom domain to us. Or maybe myagency.gov has a massive worldwide presence and you need a global cache or a content delivery network. We make that very, very easy too. And that content delivery network actually uses Amazon's CloudFront as its CDN service. And Amazon CloudFront is the other service on this board that's actually running in AWS Commercial and not running in GovCloud on US West 1. Now, to round out the picture of what else these two services in particular use, there is another third party that is not Amazon that we rely on to allow you to bring your domains, whether it's a custom domain or a CDN, to cloud.gov easily. And that service is called Let's Encrypt. And so Let's Encrypt is a third-party provider of certificates. And one of the most powerful things about using either the custom domain service or the CDN service is that the service broker, again, the automation that we've written, will go out to Let's Encrypt. It will fetch a certificate, a valid certificate for your custom domain at myagency.gov, as an example. And it will configure it correctly in the platform so that you don't need to do that. And the other beautiful part about that is it's looking at the validity of your certificate. And so Let's Encrypt certificates are valid for 90 days. Before that 90 days expiration, this service broker, again, the automation that we control, we'll go out to Let's Encrypt and it will automatically renew that certificate for you, and it'll update that certificate in the appropriate places in this infrastructure. So that's a pretty significant set of features. But I want to go back to what I said earlier, right? One of the focuses of cloud.gov is to focus on our users, for you to be able to just bring your applications to a platform, not really need to worry too much about a lot of the different compliance concerns that go into the backing of all of these services and the FedRAMP applicability of all of these services, but also not worry about any of this underlying infrastructure, right? And what we're going to look at in the next section is what actually happens when you deploy an application to cloud.gov or to Cloud Foundry in this case. But the purpose of this section is to give you a little bit of understanding of all of the different parts and pieces that go into making that experience so simple and so easy. We want to take that off your plate, so again, you can focus on your apps.
All right, so that is the first video. So I wanted to pause here and see if there were any questions in the chat. And if not, we will move on. So if you have a question. Okay, so we've got one question here, or I guess a statement. It would be great if cloud.gov users could have the ability to set up alerting at the org space app level, either through ELK. I think cloud.gov uses the free version, which doesn't provide this capability, or maybe access to the underlying cloud.gov Prometheus setup, which has this feature. That would be great. I don't know off the top of our head how we would do that, but at the end of this presentation, we will just show you how you can actually make requests to us, but we can certainly take those requests and do some investigation and see what features we can or can't add to the platform. Let's see, any other questions that we can answer on the technical overview before we move on? Okay. So it looks like there's another question. I have custom code that continuously inspects the configurations for the cloud.gov orgs and spaces that I manage. It looks for outdated build packs and at the user's roles, services, and apps to make sure it matches my baseline. Does the cloud.gov team know of other consumers using more of a Terraform, Bosch, or something similar for org space setup versus deploying infrastructure? So that's a great question. Bosch wouldn't really be applicable here because Bosch is really about virtual machines, but there is actually a Terraform provider for Cloud Foundry. And so you might want to look into that and see if that's a little bit more useful or something along the lines of what you're looking for. I know of other users and other customers that I have that have done this through things like their CI/CD systems as well. But they've often ended up, building some form of custom code also. So, okay, it looks like those are the questions for now. So let's go on to the next video and we'll talk about what happens when you actually deploy an application. So just give me 1 second to do another screen share and we will get going.
Okay, so let's talk about what happens when you deploy an application. Or in Cloud Foundry terms, you do a CF push. So CF push is the command that you use to deploy an application to Cloud Foundry. And when you do a CF push, you typically specify either on the command line or in a manifest file some information about the application. So when you do a push, the first thing that happens is that information gets stored in a database. And so it's things like the name of the application, the amount of memory to allocate to each application instance, the number of instances, the route to use for your application. And so that information gets stored in a database. And actually, before that even happens, it does a little check and it looks and it says, well, is there an application already in this space with this name? If there is, great. It'll actually just overwrite it. It also looks at the route and it says, is this route actually available if this is a new application? And that's to ensure that you don't have any collisions with other applications for other users in other spaces or something like that. So once that information is up there in Cloud Foundry, the next thing that the CLI does is it takes your app code from your laptop and it uploads it to Cloud Foundry. And Cloud Foundry stores that in a component called the blob store. And we'll see why it stores your app code here in a little bit, but it stores that information there. And this is really kind of the first phase of a CF push. This is overwriting an existing app or actually pushing a new application as well. So once we've done that, we enter a new phase, a phase called staging. The purpose of this staging phase essentially is to take that application and containerize it, to make it ready to run in a containerized environment. And the component that does that is called a build pack. And so build packs are language specific. So there's build packs for Ruby and Java and Go and Python and a whole host of other things. But the build pack's job, again, is to build that container image. And what it does is it takes your application and it looks at your application and it figures out what runtime dependencies do you have. So if it's a Ruby application, maybe you need Rails. Right? If it's a Java application, maybe you need the JRE, or maybe you need the Python interpreter. It really is dependent on that application. And the output of this build pack process is something that in Cloud Foundry terms we call a droplet. And that droplet gets stored in the blob store as well. And essentially that droplet, for all intents and purposes, it's a container image of your application that's ready to go. And that's really what the whole purpose of that staging phase is. We then enter the starting and running phase of your application. And so to run your application, Cloud Foundry can take that cached droplet, it can create a new container, and that container will have the amount of memory that you specified, it'll have the amount of disk that you specified, and it'll run that container image or that droplet in that container, in a containerization execution engine. So it'll start that droplet, it'll start your container image, essentially start your application, and the container executor is actually doing a health check. It's querying to see when does that application become available. When that becomes available, it's essentially done what we call passing a health check. And when that health check is essentially green, then your application instance is available. And so it can broadcast and basically tell the Cloud Foundry routers that this application name, or this application is now available for this particular route, and it's available here in this container. So what that allows Cloud Foundry to do is update the route table, its internal route table. And what that means is that your end users of your application can then start get routed to your running application. Now, if you specified multiple instances, then it would just essentially start multiple containers. And when those new containers started and passed the health check, the route tables again would get updated. And now your users could start getting routed to either of your instances. So when you repush your application, it already exists in the space, you repush, you're essentially redoing this entire process. However, if, let's say, we update the build pack as platform operators because maybe the Ruby runtime needed to be patched, all you as a developer need to do is restage your application. When you restart your application, all you're really doing is destroying the existing containers that are running your application and scheduling new ones.
All right, so that's a little bit about what happens when we push applications. So let's see, let me see if there's any questions before we move on to the next one. Looks like we do have one question. Give me 1 second, juggling some windows. So how is Cloud Foundry different than OpenShift or OpenStack? So Cloud Foundry is a platform as a service. So what that means is Cloud Foundry's kind of unit of currency or thing that it cares the most about is applications. OpenShift is actually a Kubernetes-based distribution. And so it's really more focused on being a more generic container as a service type provider. And OpenStack is actually an infrastructure as a service abstraction. And so OpenStack is really more of an abstraction akin to Amazon's EC2. So, you know, kind of just a different level of the things that you really care about. So in Cloud Foundry, you really care about apps. In OpenStack, you really care about virtual machines. In OpenShift, you really just care about containers. It looks like, let's see, there's another question. Where does the environment variables for an app, where are they stored? Is that part of the droplet also? No, so environment variables are actually not part of the droplet. Environment variables are stored separately in that cloud controller database, the database that I alluded to earlier. The droplet really just contains your application and all of the runtime dependencies needed to essentially run that application. And all of the meta information, all the environment variables and things are injected when you actually run that application. Okay, so that's all the questions for now. So I'm gonna keep things, I think, moving. So let's go on to the next one. So now we've deployed an application. Now we want to understand how we actually route traffic into that application or into your application instances.
So let's talk about how traffic actually gets to your application. So let's assume that your agency's website or application is available at example.gov. And you've got end users out there that you want to be able to access example.gov, obviously. So your users sitting down at their computer, firing up their web browser on their laptop. My apologies, I only know how to draw laptops from 1996. The first thing that's going to happen is their laptop is going to do a DNS lookup. And that DNS lookup is going to resolve the address for example.gov. Now your agency has its own DNS entry. Your agency is actually given a CNAME record or a canonical name record that we provide to you that allows this domain to actually be resolved. This is part of bringing your own domain to cloud.gov. But this flow actually would be exactly the same whether you were using your own domain or you were using our default app domain, app.cloud.gov. So the exact same thing would happen for example.app.cloud.gov as an example. So that DNS lookup is going to resolve the name, and that name then is going to point to an ALB, or Application Load Balancer. Now this is a load balancing component. You may have heard Amazon, the previous versions of these were called elastic load balancers. But this is actually a piece of infrastructure from Amazon that we configure and that we set up. So this is a load balancer, and it's load balancing across our Cloud Foundry routers. And so from here on out, everything is inside of Cloud Foundry. I'll just draw two routers for now, but we run multiple instances of these routers. And so this load balancer is sitting in front of all of the different routers that we are actually running as part of our Cloud Foundry infrastructure. Okay, so the ALB is essentially going to route that request to one of the routers. It doesn't really matter which one. Now you actually have multiple instances of your application running in Cloud Foundry. And your application is containerized, and so your application is running alongside of a lot of other applications, and those are all running on specialized virtual machines that are set up to run essentially lots and lots of containers. But let's say that you actually have 3 instances of your app, and I'll just shade those in. So those are on, let's say, these 3 components here. Now, just like the application load balancer is load balancing across the routers, The routers are actually load balancing across your application instances. So your request will get routed to one of the particular routers. It will do a lookup in its route table to say where are the application instances for example.gov, and it'll pick one. It basically does round robin load balancing. And so it'll pick one and it'll say, okay, here you go. I'm going to send you over here. And you get sent over here to this virtual machine that's actually running all those containers. It's actually called a cell. And that cell will get the request, and that cell will actually forward the request onto your particular application instance. Now, inside this virtual machine, all it's doing is using network address translation, or NAT, to actually get requests routed to that particular instance. Everything inside this blue space over here is on a private network, a private subnet, inside of a virtual private cloud running in Amazon. And so that's how all of your traffic actually gets from your application over to your application instances. Now, I actually drew this picture this way because we actually are running, I'd said, in a virtual private cloud for Amazon, but we're also actually running across two availability zones. And so I'll just label that AZ1 and AZ2. Now, an availability zone in Amazon terms is essentially sets of physically isolated hardware. And so the idea is if one of those availability zones from an Amazon perspective actually fails, the other one doesn't fail. And when we deploy Cloud Foundry, when we deploy all of these different components, we make sure that instances of each of those components actually land in different availability zones. So we actually have multiple routers running in each availability zone. And when you, as a user of cloud.gov, deploy multiple instances of your application, not only do we try to make sure that your application lands on different cells, that's these VMs running in the containers, but we also make sure that your applications land in different availability zones. And what that means is that if one of these availability zones fails, the other one is still running. And so from an end user perspective, the interruption is non-existent.
All right, so that's a little bit about how we route traffic, just regular traffic, into cloud.gov for your apps running there. So let me jump back in the chat real quick. And it doesn't look like we have any new questions. Okay. So in that case, let's just dive into service brokers. So there's actually two videos here. The first one's going to talk about just generic service brokers and kind of the applicability of the API to all service brokers. And then I'll give you an example, just highlighting one of the more popular ones that we have, which is the CDN service. So it looks like we actually did have a quick question come in, so let me do that. Does cloud.gov auto-scale websites? We do not currently have the autoscaler actually enabled and part of cloud.gov, but we've actually had that request quite a bit. So it is in our backlog. I don't know if it's been prioritized, but we have heard that request quite a bit. There's an autoscaler service that essentially taps into that metric stream. And then you get to set some bounds around, the minimum and maximum numbers of instances. And so consequently, you don't have to do the scaling yourself. So we are looking at that. I know we've had that request multiple times. Looks like we also have a question from Ethan. So how quickly can cloud.gov scale? So we actually run cloud.gov with reserved capacity so that we don't have to scale. There's multiple parts of this. Cloud.gov can scale your application usually in less than a second. So if you do a CF scale, it will immediately start a new container with your application to scale that particular thing up. And then really the only lag time there is how long does that app actually take to start before it passes that health check. But scaling the platform itself can take a little bit longer because we actually have to provision VMs. So if we were, as an example, getting lots of requests per second, we might want to scale the number of routers up. Really, we're bound there primarily by how long it takes Amazon to actually provision new virtual machines for us and then install the software. And so you're probably looking in orders of, tens of minutes as opposed to seconds with your particular applications. So great questions. I'm going to jump back over to the videos, keep this moving, and so we'll talk about service brokers.
So now I'd like to talk really briefly about service brokers. If you've used cloud.gov as a developer and as an end user, you've probably gone into the marketplace by typing CF marketplace. And what you see there is the list of services that you are allowed to provision on demand. So we offer things like Amazon RDS in the form of MySQL and Postgres, Elasticsearch and Redis. We also offer our external domain service. And when you're typing CF Marketplace, what's actually happening behind the scenes is that we as operators have deployed a number of service brokers. And behind the scenes, Cloud Foundry is talking to those service brokers to basically find out what they're making available. So we have a service broker for Amazon RDS. We have a separate service broker for our external domain service. And so the service brokers essentially make available a catalog of things that you're allowed to provision on demand. When you go to create a service and you do a CF create service, again, cloud.gov or Cloud Foundry is making a call to that service broker. And what it's asking that service broker to do is to provision an instance of that service. And so that could be a MySQL instance. That could also be a Postgres instance or a Redis instance or an instance of our external domain broker. The important thing is that all of the technical complexity around provisioning that particular service is encapsulated inside of the service broker. When you want to use that database for your application, you'll do a CF bind service. Bind service is again making a call to the service broker, but what it's really asking for at that point is a set of credentials that your application can use. And so the service broker will generate a unique set of credentials for your application, again, potentially making calls to something like Amazon RDS. And it'll generate those credentials, it'll return those credentials, and it'll set those credentials as environment variables for your application. Now again, you don't, as a developer, need to know anything about the complexity of, okay, how do I actually create a user in MySQL? And then how do I grant that user access to just the right resources inside of that MySQL instance? All of that complexity is hidden inside of these service broker calls to actually generate those credentials. They're exposed in Cloud Foundry by these very, very simple commands, the CF Marketplace, CF Create Service, and CF Bind Service.
All right. So that's a generic overview of service brokers. I'm just going to jump into the next video real quick, which is looking at a specific instance of the CDN service and how the CDN service broker works. And then we'll get back to questions and the chat.
So I want to use an example here to highlight the power of service brokers by looking at our external domain service and what we actually do behind the scenes, a fairly complex dance when you go to create an instance of our CDN service. So our CDN service, CDN stands for Content Delivery Network. This allows you to bring your custom domain to cloud.gov, but also to create worldwide caches of your content for high volume applications, for high throughput, or for distributed user bases that are all throughout the world. So when you use our CDN service, you are actually asked to do two things in your DNS. So as a customer, we ask you to create two CNAME records or canonical name records. The first one will start with _ Acme Challenge dot whatever your domain is. So we'll again say example.gov. The second is for your domain, example.gov. Okay? Now, these values that we actually ask you to set will correspond to values that are referenced in our DNS. So we use Route 53, which is an Amazon provided DNS service. And so these records will essentially point to records that we actually have control over. And this is important because the service broker uses these records to actually complete this fairly complex dance of getting your CloudFront distribution running with a certificate that is valid for your domain. So the first thing that the broker does when you actually provision an instance of the CDN service is it goes to fetch a certificate for example.gov. And it gets a valid certificate from a third-party service called Let's Encrypt. Now, Let's Encrypt doesn't just issue certificates for any domain. What they make you do is prove that you actually own that domain and have access to that domain so that they don't, inadvertently generate certificates that, could be used maliciously to spoof your domain. Now, in order to do that, Let's Encrypt issues a series of challenges. And so in our case, we get issued a DNS challenge. What that DNS challenge says is Let's Encrypt servers want to be able to reach out and do an NS lookup, do a name service resolution on a specific entry, in our case _acmechallenge.example.gov, and see the value that they tell you to set. Okay? So the reason that we have you set up this CNAME record is so that whatever Let's Encrypt says is the DNS challenge, we can set that in our DNS, and it is just basically a text string, so that when Let's Encrypt looks up acmechallenge.example.gov, the response that they get is the appropriate response. Now again, you aren't asked to do this anymore. In previous versions of this broker, you actually had to solve this DNS challenge yourself, but we've come up with a way that you don't need to do it anymore. You can instead just set up a CNAME record. So what we get back from Let's Encrypt is a valid certificate for your domain being example.gov. That certificate is good for 90 days, and the broker will automatically renew that certificate as long as you're using this service. So you don't have to worry about the certificate actually expiring. So we have a certificate. The next step, what the broker does at that point, is create a CloudFront distribution. So it does this by calling the Amazon APIs. And what this is doing is creating the CDN distribution. That CDN distribution that gets created has its own DNS record. It'll be, some mix of characters .cloudfront.net. We create the distribution. We find out what this CNAME record is. And we then configure the value over here in Route 53. As part of this process, you've also supplied to us what is the origin or what is the source of truth for your application. That gets configured in CloudFront. The certificate from Let's Encrypt gets configured in CloudFront. And when that distribution actually gets created, the process takes roughly 30 minutes or so. You have a running CloudFront distribution distributed worldwide for example.gov with a valid certificate. All you needed to do to actually have that happen was do CF create service and set up 2 DNS records.
All right. So that's a little bit about service brokers, and in particular, how the CDN service works. So let me hop back over here to the chat and see if there's any additional questions about this. Doesn't look like it. So as I pull up this last video here, the last video is now talking about how does traffic actually get routed when you are using the CDN service. And so this is different than just traffic going directly to applications that you have running on cloud.gov. And this is instead introducing CloudFront into that picture as well. So let's dive into this, and then hopefully we'll have a few more minutes at the end for any last remaining questions.
So now let's talk about how traffic gets to your application when you're using our CDN service. CDN stands for Content Delivery Network. And what a CDN is essentially a global cache of your content that can be cached. And so think about things like static assets, your HTML files, your CSS, your images, etc. Your entire agency site may fall into the category of something that can be cached, or you may have a subset of your site that can be cached. But our CDN service actually provides that global cache so that your user experience is better based on where they're actually sitting in the world, and so that you can support higher volumes of traffic. So once again, we'll assume that we're going to example.gov. So again, your user sitting at their computer and they fire up their browser. The first thing that's going to happen is exactly the same. The browser is going to go do a DNS lookup. Now the difference is in the response. The response that they actually get here is going to be location dependent. And what I mean by that is if you have users that are sitting on the west coast of the United States, the response that they get for those DNS entries are actually going to be different than those sitting on the east coast of the United States. Or if you have users that are over in Europe or somewhere else in the world, the responses that they get are actually going to be different. And the reason that they're going to be different is because those responses are going to be pointing to the closest Amazon cache nodes of that content delivery network. So the content delivery network service in Amazon is called CloudFront. And so when you use our CDN service, what we're actually doing behind the scenes is going out, fetching the appropriate certificates and managing those for you. But we're also creating a CloudFront distribution. And what that CloudFront distribution does is put caches of your content in different locations throughout the world. Okay? So let's assume that your user is on the East Coast of the United States. Let's say they're in Washington, D.C. or something. The response that they get is actually going to point them to a CloudFront cache. And notice I am saying CloudFront and not Cloud Foundry. That is closest to that user. And so maybe this cache is somewhere in US East. And let's say that they requested that your homepage, the index.html page. CloudFront's going to look in the cache and see, does that exist? Does that index.html page exist? And if the answer is yes, then it's just simply going to respond. If that page exists and that page hasn't expired. If the answer is no, then the flow is going to look very, very similar to the flow that we showed you not using the CDN. In CloudFront, when we set up CloudFront as a cache, the cache always has what we call an origin. And the origin, in your case, or in our case, is actually your application running in cloud.gov. And so in the event of a cache miss, this CloudFront cache is going to reach back to your application. Now the flow of how traffic gets there is exactly the same as what we drew before. You're actually going to go through an ALB. That ALB is going to actually go through the Cloud Foundry routers. Cloud Foundry routers are actually going to route you to your specific application, somewhere running in some container execution engine called a cell, and respond to the CloudFront cache. Now the only real difference here is that CloudFront is always returning information if it can. Your end user in this case never sees your application running in app.cloud.gov because CloudFront is always proxying those responses. And so if this flow actually happens, the response goes back through CloudFront into the cache, repopulating that cache before CloudFront sends the response back to your end user. Now this is exactly the same if you then instead have somebody sitting in the West Coast. The difference is going to be, again, they're going to actually hit a different CloudFront cache. But again, the only thing actually talking to your app in cloud.gov is CloudFront. It's not actually your end user. And so we actually set up our CloudFront distributions to distribute content across North America as well as in EU by default.
All right. So that is a little bit about how CloudFront distributions work, as well as service brokers. That's what we had for you today. I realize that was an awful lot of information, but this is also a bit of kind of the tip of the iceberg type scenario, because cloud.gov is pretty significant in all of the moving parts and pieces. I'm looking in the chat. I don't see any additional questions yet. So if you have any, please throw them in there quickly. Otherwise, thanks everybody for coming. I hope that this was helpful for you, help you understand a little bit about how CloudFront actually works and how cloud.gov works as well. It does look like we have a question. So in the CDN, how often do things expire? So you have some control over this actually through headers, and I don't know what the default is, but you can look up the CloudFront headers that actually control cache expiration. I don't know what the default is. I'm not sure if there's anybody on the cloud.gov team that actually knows off the top of their head. Otherwise, that'd be something we'd have to get back to you on. So we do have another question. So in the DNS records, who is responsible for the DMARC and SPF portions? I don't actually know the answer to that either. I'm not sure if one of the other cloud.gov operators wants to throw that answer up in Slack if they can, and I can read it out. And I'm not seeing anything, so I'm not sure. We'd have to get back to you on that as well. If you do have questions like that that are not answered, please do feel free to email us at support. And we can certainly get those answers for you. So I think we're out of questions at this point. Oh, there's another one that just popped in. So how easy is it for cloud.gov apps to reach back to databases that are in agency data centers, read or write? So good question. We actually don't make any restrictions in terms of reaching back into other locations from your application. So you should be able to configure a user provided service instance that points to a database inside of your data center. Where you have to deal with whether or not you can actually do that is with your agency and their data center. We don't have restrictions in place that would prevent you from doing that. We leave that essentially up to you and your firewall teams to actually handle that. But there's no restriction, and a lot of Cloud Foundry type users do that pretty frequently. So it looks like Peter was able to respond in the chat. Thank you, Peter, about the DMARC question. So DMARC and SPIF records apply to mail delivery, and we can apply those to the domain, not necessarily related to the web app DNS. We've got another question from Mike. Do you have a roadmap for services that you are adding? How do you request services to be added? So Kara, I don't know if you want to unmute and maybe take that one.
So we do have a roadmap. We don't make it publicly available. However, we do encourage people to submit feature requests through our GitHub repository, so you can definitely do that. Our roadmap has been focused primarily over the past several months on reliability and stability of the platform. And when we look at feature requests, we do take into consideration sort of the demand from our customers, as well as any kind of evolving technology or technical matters, as well as business concerns and the needs of our customers. So, but what I do recommend is that if there is a feature that you're interested in, you can definitely submit it to our GitHub repos, and that's something that we monitor and we keep an eye on. So.
And it looks like, thanks, Kara. It looks like Peter also clarified that yes, when you do reach back to your databases in the agency, we can give you an IP range of what to expect traffic to be coming from. We actually publish that on our docs site on docs.cloud.gov. All right, any additional, oh, sorry, go ahead.
If I can just jump in real quickly. I realize I didn't answer the second half or the first question. about services that are coming. Be on the lookout. We will be having the Elasticsearch and Redis brokers coming in the next couple of months. So they're in beta. They do need to go through the proper compliance and security reviews, but hopefully sometime in September, we will be getting those brokers out into production. So.
And those are the new brokers, just to clarify, that use the direct AWS backing services. So those are different than the existing Amazon, or sorry, the existing service brokers for Redis and Elasticsearch that we have today, which are not using the Amazon backed services. Okay, it looks like that's all the questions. It looks like we are pretty much out of time. So thanks everybody for coming. We really appreciate it, and feel free to reach out on GitHub or send us some support emails as well. And thank you.